Logarithms are one of my favorite topics. It's usually kind of tricky the first day as you navigate them and get to know them. But as we get going, it should hopefully get easier and easier. These are typically pretty quick one-step problems. Listening, please. Typically, this section but this chunk of information about logarithms either gets shoved into the same chapter as exponential equations, and it's just a really long chapter, or it gets its own chapter and they're two a little bit shorter chapters. So that's what happened here. We have two a little bit shorter chapters, but you'll find that there's a lot of stuff that we do in this chapter that matches up to stuff that we did with exponents, because logarithms are exponents. So that's where we're heading here. Also, do you remember when, I don't know what to do with this now.
Oh, tuck it into your knife.
Oh, good idea. There you go. Good call. I just feel like that's going to be obnoxious because they clink together. What was I going to say? Oh, do you remember when we did inverses? Oh. So we switched x and y and solved for new y. Oh. And they were reflections of each other over the line y equals x.
So this is the same thing you do.
Well, so logarithms are inverses of exponential equations, and so that's how they go hand in hand. All right, here we go. The notation's kind of funny. That's what second hour had the hardest time with. A logarithm is an exponent. So a logarithm is an exponent with a specified base. So remember, the base is the number that is getting raised to the power. So if you look at this right here, 2 is my base, 3 is my base, 4 is my base. Do you see what I'm saying? The bottom number, the big number, that's your base number. So you can write things as a logarithm or as an exponent. We can switch back and forth between the forms. And so what I told the kids that it kind of reminded me of from our last chapter, do you remember how we'd have stuff like x to the 1/2 power and we'd switch it over to the square root of x? And they were the same thing, right? They were just different notations. That's what we're going to start with today. We're going to see different notations of the same thing. So we're going to see it in an exponential format and also in a logarithmic format as well. Let's start with logarithms. So this would be my logarithmic format. Kayla, I just gave out notes packets. If you want to go grab one, they're over in the folder. I'm going to write this first and then I'm going to explain what I mean. So first of all, this was something we were struggling with because I think it was just how I was writing it. This is the word log, like a log made out of a tree in the woods. Log. To the base b, so that b is a subscript. It's down sitting below the word log. So if you were typing, it'd be down here and smaller. X should be right in line with the word log. Oh. So if I had a line right here, all this stuff is level except for the b, except for the base is down below, is equal to a. So log to the base b of x equals a. This is what we call logarithmic form because there's a log, so that's, again, mathematicians, not a creative group of people. It's logarithmic form because it's the form where we use the word log. Okay. Exponential form. Do you see the b, the a, and the x? They're the same ones. So we can switch into exponential form. So this b is your base, the a is your exponent, and it's going to equal whatever value is there. So let me give you an example with numbers. If I had log to the base 3 of 9 equals 2. Again, this is all kind of sitting on the same line together. The 3 is a little baby subscript. Because what second hour was having trouble with is they were like, is this 3 to the 9th power? That's where they were struggling a little. So again, This is all in the same line, that's a little subscript. So this, go ahead. No, not today.
Oh, so we're gonna.
No calculators today, no. All right, so this would be the logarithmic form. So this reads log to the base 3 of 9 is 2. So it always equals the exponent. So 3 to the second power, is that 9?
Oh.
Yes. So that's what it's saying. But we can also write it in the more familiar way that we're used to seeing it. 3 squared equals 9.
Is that what it's saying? But like
That's what it's saying. But again, remember how we were switching back and forth from the notations here? That's the same thing we're doing here. There are 2 different notations. There are 2 different ways to say it. I think we were even talking about in one of my classes how you use different words for things. So I went to go see a show with my girlfriends, and when we were leaving, she was looking for something, but it was dark. And so she said, "Oh, you'll have to tell me if you use the same word." She said, "I have to turn on my torch."
Torch is kind of like British though. It's British.
She's from Ireland.
Oh.
She said I had to turn on my torch, and I'm like, oh, I didn't know. I was like, I'm picturing, you know what I mean, like Indiana Jones and like this lit torch. So anyways, there are different ways to say things. She meant flashlight. So again, these are different ways to say the same thing, is how you should think of it. Does that make sense? Okay. And I kind of like torch. I've been using it because I like it. Okay. Next problem. This one says log 100. Do you see how there's no base written down there?
Yeah.
Okay. So the common logarithm is when we have base 10. And so we don't always write the base 10. So this is not usually written. So think about a square root for a minute. Here's one. Do we write the 2?
No, it's just there.
But you know it's a square root, right? There's no 2, but we know it's a square root.
Yeah.
So same thing here. If this isn't written and it just says log 100, we know if there's no base there that it's base 10. It's not that somebody forgot it. It's base 10. Just like if there's no little index number here, it's not that they forgot it. We just know it's a square root. Okay, so let's think about the answer to this, though. 10 raised to what power would be 100? 2. So that's how we're going to do these. So these are kind of mental math questions at this point. Down the road, they're going to be a little bit trickier, and we're going to need calculators and such. But for today, mental math. So this one would be the same answer, right? So these are the same questions. Because again, if it's base 10, we don't usually write it. Because if we think about what we use most commonly, we use 10 the most often. Okay. First couple examples, we're just going to switch the format. We're not going to do anything else. This is where I got out my highlighters, and I think it helped. Okay, so I'm going to start by highlighting everything in the original. Do we agree that this is an exponential notation as it stands? Right? We've got an exponent situation going on. Okay. Let's switch. Let's switch over to logarithmic form. Watch where everything goes. The base stays the base. What you want to find the exponent for is this number.
So then 5.
And then 5 goes here. It's always equal to the exponent. So this went here. That 5 and that 5 are the same 5. There's the 3. And there's the 243. So that's where everybody went. Okay? So the base in this exponential is the same as the base for the logarithm. So it's always a base. All day long it's the base. Logarithms are always equal to the exponent, so that goes here. And then what you're taking the logarithm of goes there.
But does that make sense though? Like,
Is 3 to the 5th power 243?
Yeah, but like that's confusing me.
It's a different way of writing it. So again, it's like we talked about, it's like a different way of saying the same thing.
Could you eyeball?
And one of the reasons why you might want to switch the format is because let's say you were given something in this format and that didn't make much sense to you. You could switch it over so it's exponential.
So like what I had the 5 and the 240 flipped. That would be wrong, right?
Yes, correct. That would be wrong. Okay, log to the base what? 10. Do I have to write the 10?
No.
No? Of what?
1?
1 equals
10.
0.
Oh.
Remember, the 10 is really right here. You can write it. It's kind of like if we wrote x to the first power, do I need to write the 1?
Not really.
No. It's kind of that same idea. All right, next one. My base is what?
4. Oh, no, 10, right?
10. Do I need to write it?
Yes.
No.
Oh, okay. Can you write it anyway?
So you can, yeah. Let's write it this time. Let's put it in there. Log to the base 10 of
Like 10,000 or something?
10,000 equals
10 to the 4th?
4. Yeah, 10 to the 4th because we need 4 zeros.
Also,
So again, these are just switching back and forth between the formats. I'm not doing any math. I'm rewriting it into a different form. All right, let's do the same thing. Look down at example 2. We're going to do the same thing, but we're going to switch the other way. So we're going to switch from something that's written as a logarithm into the exponential.
oh,
So this is my exponent. I'm going to highlight again for this one, just for the first one.
2 to the 30.
I'm keeping the values the same as what they were in number 1.
So 2 to the 30 equals 8. Right?
So it would be 2 to the 3rd equals 8. And it should make sense when you plug it in, right? So 2 cubed is 2 cubed 8.
Yes.
So it should be a situation, like a statement that's true, a statement that makes sense. So this is the 2, and this is the 8. So again, if it helps you, you could also draw like arrows in there to kind of show where everything's moving. Whatever works best for you. All right, let's look at the next one. How would I write the next one?
10 to the negative 2 equals 1 out of 100.
Yeah. And let's think about why this is true for just a minute. Think about it's not negative for a second. 10 is just a 2. What is 10 squared? Almost 100. So the negative is the piece that moves it down to the bottom to make it a fraction. Okay, write the last one. You can do this. We've done 2. You do the last one on your own. And then look at mine and make sure we match.
Yeah, we match.
You match? Okay. All right, so there are some special properties of logarithms. These are logarithms that are really easy to find. So look down here first, and then I'll put the formula up here in a second. So remember, this is saying 7 to what power is 7? 7 to what power is 7? 1. So anytime your base and what you're taking the logarithm of match, it's going to be equal to 1. So the way that we typically write that is log to the base b of b equals 1. So when those b's are the same, and we have to specify b has to be bigger than 0 in order to do this whole process. All right. Similarly, 8 to what power equals 1?
Oh, 0. 1.
0.
1 or 0.
0. So if you have log to the base b, b could be anything as long as it's greater than 0. Again, we're not going to get any values that are less than 0. It's always going to be 0 here. So log to the base b of 1 will always equal 0. So if what you're taking the log of is 1, the answer is always 0. Flip when you're ready. We've got a couple more that we're going to do. Again, we're going to save graphing for tomorrow. These we're going to evaluate, and again, no calculators. I know calculators are like our go-to, and they're kind of our security blanket and all those good things, but not today. Don't use it today.
Oh God, what is the 10 million?
All right. This is saying 7 to what power is 49?
2.
2. So again, I'm going to give you nice numbers here. I'm not going to give you like crazy go nuts numbers that don't make any sense that you can't do in your head. If I'm saying no calculator, truly I'm going to give you stuff that you can do with no calculator. Okay, this next one, the trick is counting the zeros.
There's 7. So
7.
is it to the 7th?
So it is to the 7th power, 10 to the 7th. And did they have to write this 10 as the base?
No.
No. All right. We're going from 3 to 3. So that would be a 1, right? But how do we go from a whole number to a
Yeah,
fraction?
you flip it, so it's negative.
Negative 1. Yep.
Oh,
And then here's one of our special ones. 5 to the what is 1?
0.
0. All right, this one's a little bit more of a thinker. We want to go from 25 to 5. What would you need to do to 25 to make it a 5?
Do you have to put it to the 5 to the 3rd? Oh, no, to the 2nd.
If I did it the second,
Wait, really?
to the 1/2. It's 1/2 because it's square root. Do we agree to get from here to here we need to square root?
I guess.
Yeah. So if you need to square root, that'd be the 1/2 power we saw those last chapter. If it was the cubed root, it'd be 1/3.
So we're square rooting 25, right? So
Yes, because you want to go from 25 to 5, so you'd have to raise it to the 1/2 power to make that happen. I'm going to give you a bonus problem, so don't put your stuff away after this one. 2 to what power is 16?
I don't know.
4. Yep. And if you don't know, like these are, that's the time I'd be like, get out your fingers and use them. All right, last one. I want you to add this one. Okay. First of all, I ignore that there's a fraction for a moment in time. If I just needed to go from 5 to 125, what power do I need? 5 times 5 is 25 times another 5.
So 25
So it's 3. Now, anytime you have to traverse this gap from being a fraction to a whole number or going a whole number to a fraction, you always need a negative. So the negative is the fix to get us from a whole number to a fraction or a fraction to a whole number. So the 5 takes us to 125. The negative 3 is what flips it. We're going to graph tomorrow. So tomorrow is graphing day, not today. So the homework is, I'm going to switch it out because I already wrote it down last hour. This is the homework, and I'm going to put my book under the doc cam so you